Alright, welcome to this series of videos. So in this series of videos, we are going to cover some binary tree traversal algorithms, such as pre-order traversal, post-order and in-order traversals, level order traversal, and zigzag order traversals. So in this series of videos, we will emphasize the iterative way of writing the code. There are two reasons. First is that the iterative way help better understand the details. Secondly, in the iterative fashion, we can incorporate more complex logics so that we can solve more complex problems with these traversal algorithms as basics. With that said, let's start from the pre-order traversal. So this problem is 144. So given a root of a binary tree, so we are required to return the pre-order traversal of its nodes values. So the pre-order traversal is the following. So we first visit the root, and then we visit the left subtree, and then the right subtree. When we visit the left subtree and the right subtree, we do the same pre-order traversal. So that's the definition of pre-order traversal. So let's look at one example here. So here we first visit the root, so that is 1. So in the output of example 1, we have 1. And then we look at the left subtree. So here the left subtree is null, so we turn to the right subtree. So we first visit the root of the right subtree, that is 2, so we have 2 in the output. Then we look at the left subtree of 2, so that is 3, so we return the 3. Then we examine the left subtree and right subtree of 3, because here 3 is a leaf node, so we move to the right subtree of 2. But the right subtree of 2 is null, so we stop here. So the return or output is 1, 2, 3. So this is example 1. So example 2 is a trivial example, and example 3 is a special case where the root or the tree is a single node tree. So we return 1 in example 3. So the constraint is sort of routine, which about the number of nodes and the range of node values. So as we mentioned at the very beginning, so we are emphasizing on the iterative way of writing the code, but we also take 1 or 2 seconds to write a recursive solution. So as commented by the follow-up, recursive solution is sort of trivial. So but for completeness or for understanding the definition from this perspective, we do it here. So here, let me first write the recursive way. So for this, I'll first check the special case, if not root. So I'm going to return the empty list. So that's a static case. And then we do the generic case. We just need to return, because we first visit the root. So we're going to put this root value, and then do list concatenation. Then we do self call, so self pre-order traversal. So we need to first traverse the left child or left subtree, that is root left, and then we do traversal for the right. So that's about it. So now let's test the code. Yeah, it passes this the test cases. So now let's move to the main task, that is the iterative way. So I'll copy the function signature, and then we'll rename this as v1. So for the iterative way, so I'm also first treat the special case, that is if not root. So we're going to return empty list. So this is a routine, and then we're going to initialize a variable called result, whose final state is what we want to return, and then we're going to initialize a stack. So I'll call this stack, and then we're going to iterate. So first we will initialize the stack as root. So this stack will store the nodes we actually traversed. Then we do the while loop, while stack. Then I'm going to pop the stack to get the node. The node is stack pop. Then we're going to put nodes in the stack for it to be visited. So here is the theme. So when we do the pre-order traversal, so it's parallel to the DFS traversal for general graph. However, so in the binary tree case, there's a concept of left or right. So we need to pay attention to the order of the nodes added to the stack. So here we need to first add right, then left. So if node right, so we are going to stack append the node right, and then we check left. If node left, we are going to stack append node left. So that's the case. So after that, we are ready to return the final state of the result. So let me just make a comment. So here we first, so after we visit the root, we first add the right and then add the left. The reason is that stack is last in, first out. So because left is last in, so we are going to first pop left. So we have left, root, and right. So that's exactly corresponding to the definition of pre-order traversal. So let's check the test cases. So so what's the problem here? Oh, I see. So we forgot to update the result. So we update the result by node value. So then we test it. Yeah, it passes all the cases. I guess that's about it for the pre-order traversal. So one point we want to emphasize again, maybe the order we put the right and left node to the stack. So that's about it for this video. Thank you very much.